This YouTube video is an update on the latest insights into galaxy formation as of July 1st, 2022. And the news is good. The latest insights, paradigms, theory concerning galaxy formation is actually a simplification on the previous theory. A simplification that has made things clearer than before, not more obtuse. A simplification that makes it easy enough for someone like me to understand and something that somebody like you could understand. The beauty of it is its simplicity, in fact, because in science, this is called Occam's razor. Usually the simplest solution is the correct one. And this latest of theories is so simple that you will understand it, you will intuitively understand it, and you will learn these things in just a few minutes if you stick it out. And that is this. Number one, what creates galaxies? 2, why they have special shapes, why there are all kinds of weird ones. Most importantly, about 75% are spiral galaxies. And really, you'll soon see why. The spiral galaxies are the key galaxies in terms of gleaning information. 3, what is dark matter and how does it work? And 4, and perhaps most profound, is why DM, dark matter, must exist. Because with the presence of dark matter, it creates a model for creation of galaxies, creation of things like this spiral galaxy. These are real pictures, by the way. These are not artist's interpretation. That's what pops out of the Big Bang. That's what pops out of a chaotic event we call the Big Bang. How does this beauty pop out of a chaotic event? That's always puzzled me. And it's only in the last 2 or 3 years that they have finally figured out this paradigm, this question. How does this result? And this is what you're about to learn, and it is amazing. So let's just wipe this off and get right to it. None of this is hard. None of this is confusing. You're going to understand it all. The evidence shows, obviously, there's a Big Bang occurred. We have the universe. We have galaxies. So working backwards, we try to figure out how did it happen. And so far, this is what we figured out. We know that the universe began, and we can represent it by a small sphere. And over time, this sphere increased and increased in size, expanding universe. Now, this increase in size, for the first 300,000 years, is going to be visually always invisible to us for this reason. Because for the first 300,000 years, whatever was the universe was so dense and so hot that light itself did not exist and could not escape. So it isn't until after 300,000 years approximately that the universe became transparent, that light was visible and was possible to see things. Now, amazingly, our science and technology is so advanced that we can actually detect that light today, that first light that popped out. Remember, what we're seeing at that first light is like when a baby pops out. For the first 9 months, you see nothing, but there's a lot of development going on. But once that baby pops out at the 9-month mark, you can snag your iPhone and take a picture of the baby. And the picture you get of that baby when you take it is this. This is the cosmic background radiation picture. You probably have heard that. I'm going to explain to you what it is. It's not difficult. It's very easy. I explained that for the first 300,000 years, there was no light. But after that, the universe became transparent. When it became transparent, its evidence started to be sent out via light. this light is still there to this day. Red shifted into radio waves, which are very, very low energy, but radio waves that can be detected, and we call those radio waves part of the light spectrum, part of the electromagnetic spectrum, radio waves. We call that the cosmic background radiation. In essence, it's your very first picture of the baby, of the universe. It's not when it was born, I guess it was born then, but it was created when the sperm and the egg got together. So this is 300,000 years later. It's popped out and we've taken a picture, and that's the picture. And what it shows, the picture, if you look at it carefully, is that even though the Big Bang and what it created inside here was incredibly dense and incredibly hot, you can imagine, millions and billions of degrees hot. It created a lot of entropy, a lot of confusion. There was no organization, if you will. Nothing organized could come out of something chaotic like a Big Bang. And I use the word chaos very specifically. It's not random, it's chaos. Chaos theory involves randomness with an attractor, or something that limits the randomness, if you will, so that there's recognizable patterns within the randomness. But I digress. At the point when we first see the universe all clumpy like this, what's happened is that even though there was a lot of like heat and intensity and density and matter inside the expanding universe, when it finally popped out, you could see that it was clumpy. This is very important, the clumpiness. The matter tended to be sort of clumped together. This is critical because it's that clumpiness that later manifests itself in the form of galaxies. The clumpiness, or the early prototypical galaxies, the matter sort of starting to hang together gravitationally, the stuff that eventually will form into a galaxy, okay? Certainly doesn't look like anything like a galaxy at this stage, does it? But I'm going to explain to you why it will look like this. How this turns into this, and why this turns into this is not hard. It's actually incredibly easy once you put into place dark matter. And dark matter is not a phantom. Dark matter has been proved by numerous lines of evidence that it must exist. Yes, they haven't found it, but that doesn't mean it doesn't exist. The Higgs boson was presumed to be there for decades because it had a good theory behind it. It was only recently that we found it. I'm sure the dark matter particle is the same. We're going to find it because it has to be there, and you're soon going to see why getting to this can only happen with dark matter, and very easily. That's the point. So let's get on with this. So popped out now. So having popped out of the Big Bang, if you will, from the map you can see, we can think of it, just to generalize and make it easy, we can think of this globiness that went on to become galaxies as sort of patches. All kinds of sort of blobs. These, of course, are spheres. Matter and energy and are always going to attain the state of least energy, and that'll be spheres. Things are going to form spheres. So they're going to be all spheres. As you would expect in a chaotic event, there's going to be no uniformity to the spheres. You're going to have some small spheres. You're going to have some big spheres, right? That's important, the size of the spheres. Also, the contents of the spheres are going to change. There's basically three things in the spheres, only three: hydrogen, helium, a tiny bit of lithium, hardly worth mentioning, and, it seems, the dark matter particle. Okay, so in each of these little blobs, there's going to be some hydrogen, some helium, some dark matter. Most galaxies show that it's predominantly dark matter. 85% of the mass, as determined again by many lines of evidence. 85% of the matter is dark matter. So hydrogen and helium, which later, of course, go on to fuse the higher elements, but I digress. Hydrogen and helium are tiny players, really, in the big scheme of things. It's the dark matter that's the puppet master in this. So each of these little spheres of what popped out of the Big Bang, that randomly popped out, different sizes, different compositions. The only thing they had in common, and this is the maybe most important point, is that probably all, maybe not all, but almost all, were imparted. We gotta rub out to put this in here because it's so important. Angular momentum. That sounds fancy, but it's not. It means they were spinning. They were spinning like everything else in the universe that was created. It's spinning. Planets spin, moons spin, the planets spin around the sun spins around the galaxies spin around themselves in their common center of gravity. Everything is spinning. So it is no jump to think that these balls, all these different balls that were split out, right, all are going to have different compositions, be of different sizes, and be given different amounts of spin. They're all going to be spinning balls, so we'll get to what that means exactly, but that's the important thing. They're spinning. They may not all be spinning, and I'll explain that to you at the very end when we discuss another important principle that we need to add in. So let's just take a look then. Now we have to get down to the micro details. Let's take a look at one typical bubble, for example, like the Milky Way. Now, what could have popped out of the Big Bang? Certainly not the structure of the spiral galaxy. How could such structure pop out of a million degree inferno and be so beautifully formed? Come on, let's be serious. What obviously popped out is in these spheres, you had only three things, remember. And you had dark matter, you had hydrogen, and you had helium. These spheres, I'm using poor terminology. What they are really halos or clouds, right? Because hydrogen and helium alone are going to be a cloud. They're just like a dust, like a gas. And dark matter is probably even much smaller than hydrogen and helium, although its total mass, if there's so many of them, its total mass is going to be higher. But it's also a tiny little thing. So let's look at the distribution of what we would expect. And not only that, but the distribution that's evident today. And this is what the studies show, where the dark matter is and where the matter is. The hydrogen and the helium were more concentrated in the center. Let's do that. And then as you go out, less and less. The dark matter, time to introduce a new color, don't you think? The dark matter was also more concentrated in the center and less as it went out. And in fact, the present studies show it went out probably further than the regular matter. So there was more dark matter than there was the volume of the dark matter was spread over a much greater volume, and the matter, hydrogen, helium, was more towards the center, the concentrations. Of course, at the very center, all this matter and probably some dark matter got in there. The very center eventually formed the central massive black hole. That's at the center of all spiral galaxies. But I digress. That's not important for this theory now. So what do we have now? What have we established? That we have a kind of a cloud. I'll just represent it like that, spherical in shape. And in it, the matter, hydrogen and helium, and the dark matter particles are all sort of concentrated more to the center. Again, the important thing is that it's spinning. This whole thing is spinning. Spinning, it's rotating. That's the critical element to all these balls. So the hydrogen, helium, dark matter are all at this stage all mixed up. You have entropy, you have the randomness of the Big Bang still there. There is no cohesion. There's nothing beautiful having been formed yet, right? But the key is, because everything is spinning, we have to now digress to a very important thing. And before, we have to sort of jump away from our ball here to discuss something very important in astronomy, and that is accretion. Disks. Accretion disks are ubiquitous in space. The rings of Saturn, accretion disk. The solar system, an accretion disk. Every type of star, from a white dwarf to a black hole, accretion disks. They're there, and they're there for a reason. And that is that when you have something at the center, if you will, and then you have angular momentum and things orbiting around a central mass, due to complex physics involving friction between particles bumping into each other, it's a natural phenomenon that all the matter will fall into the equatorial plane of the object and start to rotate around it. And that's called an accretion disk. So accretion disks are a natural process. Of course, we see them all the time. This happens anytime a bunch of stuff is orbiting around an object. It will naturally accrete to a disk. So we see it all the time in space. It is a natural process. So let's continue from there. So let's go back now. Oh, of course, this is important to mention. So you say, well, problem solved. Problem solved, doctor, because we have a central black hole at the center of our galaxy, and you have all this stuff spiraling around it. Then, well, there you go. You've got your accretion disk. The galaxy is an accretion disk. No. The problem with that is that black hole in the center of the galaxy is probably like 0.0000027% of the mass of the galaxy. In other words, it's not like other accretion systems where all the mass is concentrated in the center and stuff floats around it. Yes, this supermassive black hole will have an accretion disk, but its size is only sufficient to support an accretion disk like that. Just right around it, you're going to have, yes, you'll have an accretion disk. It's not nearly big enough to create an accretion disk of this size. There's got to be some other source of gravity that's doing that. And they've discovered what that other source of gravity is. It's the dark matter. The dark matter provides not only the glue, but the impetus for spiral galaxy formation and disk galaxy formation. And I'm going to explain that to you why right now. It's beautiful. It's a beautiful concept. And that's this. So if you imagine this, you have a sphere, and it's turning like this. And inside the sphere, you have hydrogen, and you have helium, and you have the dark matter particle, and it's turning. Sort of set it up at a weird angle, didn't I? Anyways, the hydrogen and the helium in this turning sphere, and the influence of the dark matter, which creates an apparent gravity at the center, which is super huge, in essence, is forms an accretion disk. What happens is that the effective gravity of the dark matter takes its effect, and over time, the heavier elements, hydrogen, helium, and the elements later forged in stars, will migrate towards the center along the equatorial plane and form an accretion disk. In other words, the whole galaxy is an accretion disk due to the gravitational influence of the immense cloud of dark matter that is part of the whole complex. They were all set off spinning at the same time. The hydrogen and helium dark matter is concrete. Important question you ask, but what about dark matter? Won't it just accrete and sort of defeat everything? No, that's the beauty. They've analyzed the properties of dark matter, and dark matter only has gravitational influence on other objects. It doesn't experience the other forces. What that means in essence is that it can't bump into itself. Literally, it can't bump into itself. When my two hands come together like this, it's because electrons are both negative on both sides, and the electromagnetic force prevents them from going together. Because dark matter does not exhibit the electromagnetic force, it does not experience friction, and therefore will not accrete. The normal matter will accrete in to form a disk in this rotating sphere of dark matter, while the dark matter itself will just continue to spin on its merry way. Probably to this day, we have the dark matter just continuing its spin. And of course, the matter is also just continuing to spin, the angular momentum, and that's the manifestation we're seeing right now of the galaxy rotating. All spiral galaxies are rotating. The reason all spiral galaxies are rotating is that around this, we can draw a sphere. There's an even bigger sphere of dark matter that's turning in the same direction and still is in a spherical distribution. And the matter accretes and accretes and accretes down to form the disk shape. Of course, why the spirals form, why so much happens, gets incredibly complex. This theory does not explain why you get spirals. This theory explains why you get organization out of chaos. What causes that initially diffuse spinning matter to accrete down into a disk? In fact, it's so simple a solution to this problem that it has to be right. If I were to look into the sky and see a spiral galaxy, if you use the top-down argument and thought logically, you would realize that the only way it could possibly exist is if it was indeed being spun by an even larger conglomeration, and those are dark matter clouds. Again, initially everything was random, but it was all spinning. It's just chaos theory, the special attractor being the equatorial plane. It's matter, dark matter, gravity, and accretion disk physics. Simply explains everything. And that is it.